Building software with AI right now is, well, it's kind of like telling an overeager contractor, hey, build me a nice house, and then you just turn around and walk away.
Yeah, and you might come back to a beautiful mansion, or, you might come back to a shack with absolutely no plumbing.
Right, exactly.
Ah.
Welcome to this custom deep dive. Today, we're really digging into something I think we've all felt, which is AI fatigue.
Oh, absolutely. That exhausting feeling of just getting totally lost in messy, contradictory chat outputs.
Yeah, and it doesn't matter if you're, a seasoned developer trying to catch up on the latest workflows or just a curious learner trying to finally get a side project off the ground. You've probably felt this pain.
You definitely have. I mean, the speed is certainly there with AI, but without a blueprint, you're completely at the mercy of its guesswork.
Totally. So to solve this, we are pulling from some really comprehensive course notes developed by JetBrains and DeepLearning.AI. We're looking at a massive paradigm shift called spec-driven development.
Right, or SDD for short. Spec-driven development with coding agents.
And our mission for this deep dive is to give you a shortcut to mastering AI-assisted coding. We want to help you shift from that frustrating, chaotic approach into becoming what's essentially an AI software architect.
Which is a much better place to be.
Okay, let's unpack this. What exactly is this chaotic approach? Because I know the industry has a highly specific, kind of funny name for it right now.
Yeah, they call it vibe coding.
Vibe coding.
Right, vibe coding is basically when you use these vague reactive prompts, you just tell the AI, make the button green and big or add a login screen.
And then you just sort of look at the output and you vibe with it.
Exactly. You vibe with it, and then you endlessly chat back and forth to correct the inevitable errors.
Which, I mean, let's be honest, that feels amazing for the first 10 minutes.
Oh, it feels like magic.
You ask for a button, you get a button.
Yeah.
But JetBrains and DeepLearning.AI point out that vibe coding completely collapses at scale.
It does. And it collapses because of a fundamental mechanical limitation in AI models, which is called context decay.
Okay, context decay. Is that just like the AI forgetting what we talked about an hour ago?
Essentially, yes. But it's actually a structural limit. You see, large language models are inherently stateless.
Meaning they don't have true memories.
Right, they don't. Instead, they have a finite context window. It's a maximum number of tokens or words that they can process at any one time.
So as your chat session drags on and on.
That window fills up.
Yeah.
And to fit your new instructions in, the model starts overwriting its earliest instructions.
Yeah.
It literally forgets the foundational rules you established at the very beginning.
And then it begins to hallucinate.
Exactly. And you experience massive architectural drift.
Wait, isn't the whole point of AI that it does the thinking for us? I mean, if it's just going to forget everything, why are we suddenly writing all these formal documents and specifications? Why not just open a new chat window?
Well, what's fascinating here is that the AI actually is still doing the heavy lifting of writing the syntax, but you have to guide its intent permanently. The course notes use this brilliant analogy to explain it. They call it the compiler analogy.
Oh, I love a good compiler analogy.
Right. So in traditional programming, a human writes human-readable code like C++ or Python, and then a software compiler translates that into raw machine code.
The ones and zeros that the computer actually runs.
Exactly. But in spec-driven development, plain English becomes the new programming language.
So I write a plain language spec, and the AI agent acts as the compiler.
You got it. It translates your English into Python or JavaScript, and the leverage you get from this is incredible. They call it downstream amplification.
Downstream amplification. What does that look like in practice?
Well, say you make a tiny edit to your plain English spec. You just change one line from use MySQL to use SQLite.
Okay.
That tiny change prompts the AI compiler to automatically rewrite hundreds of lines of underlying code for you.
Wow.
And because you boot up the agent with a persistent version-controlled specification document every time, you completely eliminate that context decay.
Because it always has that permanent anchor to read from.
Exactly. It doesn't have to rely on a messy chat history.
That sounds incredibly powerful, but I do have to push back a little on the time investment here. Because the whole appeal of AI is that it codes in seconds.
Right, the speed.
Yeah. Am I really going to sit down and write a formal document for an hour just to save the AI from forgetting things?
So the course provides a highly practical metric for exactly this. They call it the 3-minute rule.
The 3-minute rule. Oh,
Yeah.
yeah.
If an AI agent is going to write code continuously for 20 to 30 minutes.
Which, just to clarify, translates to several hours of traditional human coding.
Exactly. So if it's going to work for that long, it is always worth pausing to spend just 3 or 4 minutes writing a crystal clear spec first.
So 3 minutes of planning buys you hours of correct execution.
Right. It's about front-loading the intent.
That makes total sense. 3 minutes of planning to save hours of debugging. But I'm trying to picture this physically. Are we talking about like one massive Microsoft Word document full of endless requirements?
No, not at all. It's actually highly structured into plain text markdown files.
Ah, Markdown. Okay.
Yeah. At the macro level, you build what the course calls the project constitution. This is that immutable foundation we talked about.
The thing that stops the AI from drifting.
Right. And it consists of three very specific files. First, you have mission.md. That defines the why, your core vision and your target audience.
Okay, the why.
Then you have techstack.mdd, which defines the how, the exact tools, the frameworks, all of that.
Right.
And third, you have roadmap.md. That's the when, breaking the project into chronological phases.
And the sources actually walk through running an example project to demonstrate this, right?
They do. It's a satirical app called Agent Clinic.
Agent Clinic. I love that.
Yeah, it's a full-stack web app designed as a medical clinic for overworked, hallucinating AI agents that need context infusions.
That is such a great joke premise.
It is, but building its constitution was highly instructive. For example, by locking down the tech stack file, the human architect dictated that the agent must use Ono.
Which is just a super lightweight web server framework, right?
Exactly. And they specified Squalate for a simple local database and Vitest for automated testing.
So the agent isn't just left guessing which of the thousands of available tools it should use on any given day.
Right. You remove the guesswork entirely.
Okay, here's where it gets really interesting. Let's say I'm starting a brand new project. A greenfield project, as developers call it.
Sure, greenfield.
How do I actually write this constitution? Am I just sitting there staring at a blank screen, typing out my tech stack all by myself?
No, and this is the beauty of spec-driven development. You actually co-author these documents with the agent.
Oh, really?
Yeah. For a greenfield project, the agent uses a tool called Ask User Question. It basically acts like a consultant interviewing you.
So it asks me what I want.
Exactly.
Yeah.
It asks about your trade-offs. Like, do you want a playful tone or a serious tone? Or are we prioritizing speed or data fidelity?
And I just chat my answers back.
You just chat your answers, and the agent takes those answers and autonomously generates the formal markdown files for you.
Okay, but what if I'm not starting from scratch? What if I'm jumping into a brownfield project?
Legacy code.
Yeah, legacy code. So if I have this old, unspec'd, messy code base, you're saying I don't have to write the Constitution from scratch. Does the AI essentially, like, clean my room and draw the blueprints for me?
That's exactly what it does. In a legacy environment, you basically unleash the agent to autonomously explore your workspace.
Just let it loose.
Right. It crawls through your existing code, it reads your old README files, scans your to-do comments, and it reverse engineers the Constitution.
That is wild.
It really is. It figures out what your tech stack actually is and extracts all your scattered open tasks into a clean, prioritized roadmap.md.
And then I just review the generated files and approve them.
Yep. You just review and approve.
It's like bringing in an auditor who organizes your entire business strategy overnight.
That's a great way to put it.
So the Constitution prevents the AI from forgetting the big picture. But a Constitution is just this broad governing document. It doesn't tell the AI how to lay the actual bricks on a random Tuesday when I just want to, build a login page.
Right.
So how do we translate that macro blueprint into day-to-day coding?
Well, that brings us to the micro level, which is called the feature loop. Every single new feature follows a strict, repeatable cycle. Plan, implement, validate.
Plan, implement, validate. Okay.
Yeah, and the crucial first step here relies on a golden rule from the JetBrains notes. The rule is one feature, one isolated Git branch.
One feature, one branch. Let me guess why. If we're on the main branch looking at the entire code base, we're filling up that context window again?
Exactly.
But by isolating the feature on a brand new branch, we give AI a blank slate.
Spot on. You completely clear the agent's chat history and check out a fresh branch. The agent doesn't get muddled by totally unrelated parts of the app. Its memory is preserved purely for the specific task at hand.
That makes perfect sense.
And once you're on that fresh branch, you generate 3 micro-level specs.
More markdown files.
Yes. You have requirements.md for your constraints, plan.md for a step-by-step tactical approach, and validation.md for the acceptance criteria.
Okay, so once I have those 3 micro documents all set up, how hard do I have to prompt the AI to actually write the code?
Almost not at all.
Really?
Because your plan outlines the steps so clearly, your actual implementation prompt is literally just one sentence. You just type, implement the remaining task
Yeah,
groups.
that is it.
That is it. The agent reads the plan and writes the code autonomously.
That feels like a superpower. But I mean, it doesn't always go perfectly, right? The sources mention a really specific anecdote about something called the nano trap.
Yes, the nano trap. This is the ultimate aha moment for why human specification matters so much.
What happened?
Well, during phase 1 of the agent clinic build, the agent was tasked with building the homepage. The human spec simply asked for a nano landing page.
Nano, meaning very small. Right.
So the agent built it, and it was technically functional, but it was entirely unstyled. Nano literally meant raw text on a screen. There was no HTML header, no main content area, no footer.
Okay, see, if I'm a developer and the agent messes up by giving me a basic nano page, my very first instinct is to open the IDE and manually type in the missing HTML header tags myself.
Which is what most people would do.
Right, because it would take me maybe 30 seconds to fix. Is that what I'm supposed to do?
This raises an incredibly important question, and the answer is a resounding no.
No?
No. That instinct is actually the most dangerous pitfall in AI coding. The fundamental rule of spec-driven development is fix via the agent, not by hand.
Wait, really? Even for just a simple HTML tag, that seems incredibly dogmatic. Why wouldn't I just fix it?
Because if you fix it manually, you trigger something called artifact drift. Yes. The moment you type that HTML tag yourself, your specification documents instantly fall out of sync with what is actually living in production. You might know that you added a header, but your plan and your requirements files do not.
Oh, I see. It's like updating the physical plumbing in a building, but forgetting to update the blueprints.
Exactly.
Eventually, no one knows where the pipes actually are, and the next contractor comes in and accidentally drills straight through a water main.
That plumbing analogy hits the nail on the head. In software, we call the resulting mess cognitive debt.
Cognitive debt.
Yeah. You become mentally exhausted trying to remember all the invisible differences between your written blueprint and the actual code base over time. And that is the true root cause of AI fatigue.
Wow. So the fix is just to tell the AI, hey, update the plan to include a layout with a header, and then update the code.
Precisely. The agent updates the markdown specs and the application code simultaneously, keeping everything perfectly in sync.
That is brilliant.
But to manage this without burning out, you do have to calibrate your review altitude.
Review altitude, like how closely I'm zooming in on the code.
Yes. You need to review at the level of high-level business logic. The course uses a great phrase for this. An omission isn't a failure.
What does that mean in practice?
For instance, if the agent writes inline prop definitions in TypeScript.
Which just means it defined the data shapes right inside the component instead of in a separate, cleaner file.
Exactly. If it does that, don't sweat it.
So basically, don't argue with the AI over grammatical style choices if the underlying math is correct.
Yes, exactly. If it really bothers you, just instruct the agent to extract them globally later. But do not waste mental energy reviewing every single line.
Right.
And if you really want a deep line-by-line validation, the notes introduce a wildly advanced tactic for that. It's called spawning subagents.
Subagents, you mean like my AI is hiring its own AI subcontractors? How does that even work?
It's exactly like that. You essentially tell your main agent, hey, pause what you're doing, spin up a secondary AI inside an isolated container with zero memory of our previous chat, hand it just the code for this one login button, and ask it to find security flaws.
That is amazing.
Yeah, that subagent has a totally fresh context window. It does the deep check, hands a report back to the main AI, and then deletes itself.
You get a deeper view without polluting the main agent's memory. Okay, I love the idea of subagents doing the busy work.
It's a lifesaver.
But I have to ask, if we are constantly stopping to write specs, update blueprints, review subagents, don't we lose the blazing chaotic speed of AI? Doesn't this just slow everything down?
I get why you'd think that, but there is a core philosophy here. Run slow to run fast.
Run slow to run fast.
Yes. The preparation takes discipline, but it allows you to move incredibly fast during execution because the code actually works.
Right, you're not constantly fixing broken things.
Exactly. And to manage this pacing, SDD introduces an intentional replanning pass between feature branches.
And a replanning pass is what exactly? Just taking a breath.
It's a deliberate pause to clean up technical debt and absorb changing realities. Let's say your product manager suddenly bursts into the room and demands mobile responsiveness because 40% of your users are on phones.
Oh boy. If you were vibe coding, you'd be ripping your hair out trying to rewrite everything manually.
Right, because the AI has already built half the app, assuming a desktop screen.
Yes. So what happens in SDD?
In SDD, during a replanning pass, you simply instruct the agent to update the core constitution to require responsive design going forward.
And it just cascades those constraints down to all future features.
It instantly cascades them down. This is also where you inject testing, by the way.
Right.
You can tell the agent to add Vitis to your tech stack, and it systematically goes back and writes unit tests for your previous features.
That is incredibly systematic. But the notes also detail something called an MVP extreme test.
Oh, yeah.
That sounds a little less systematic and a bit more explosive. What is that?
It is effectively a massive stress test. When management demands a minimum viable product, or MVP, you can bundle several future phases together.
Like all at once.
All at once. In the Agent Clinic example, they bundled phases 3 through 7, therapies, appointments, dashboards, everything. They instructed the agent to implement it all in one sweeping code generation step.
Wait, so we're using a massive automated code generation pass, not as a reckless shortcut to finish the app, but as a deliberate stress test for our own planning.
That is exactly the point. It exposes the holes in your planning.
Give me an example of a hole.
Well, during this massive implementation, the human developer realized their spec simply asked for a therapist column in the database.
Which is pretty vague.
Because it was too vague, the agent had to guess. So it built a column named therapist name.
Ah, the aha moment again. The AI didn't fail, it just exposed that the human spec wasn't specific enough.
Yes. You review the MVP, you see where the AI was forced to make assumptions, and then you responsibly go back and tighten up your specs before locking anything down.
That makes total sense.
It proves that if your foundational constitution is solid, the agent have enough context guardrails to generate a highly functional demo in a single bound.
Okay, so we've built the perfect workflow. We have a constitution, we have feature loops, subagents, extreme testing.
Everything you need.
But we really need to talk about the elephant in the room here.
What it is.
What happens when a brand new, vastly superior AI model drops tomorrow? Because let's be real, they drop every week right now.
They really do.
Are all my specs, all my custom workflows permanently locked into whatever specific agent I started with?
No, and this is perhaps the most important concept in the entire DeepLearning.AI course, agent replaceability.
Agent replaceability.
Yes. Because you are anchoring your project in open plaintext markdown standards, you are completely preventing vendor lock-in.
So the agent is essentially just a commodity.
A swappable commodity, yes.
Yeah.
Your written specification is your permanent, durable asset. And this portability is driven by open standards. So the two major ones right now are MCP and ACP.
Okay, let's break those acronyms down. What is MCP?
MCP stands for Model Context Protocol. Think of it as the universal USB-C port for AI.
Oh, I like that.
It standardizes how an agent connects to external systems. So whether you use Agent A or Agent B, as long as they support MCP, they can plug into your local database or your secure API documentation the exact same way.
Well, if MCP is the USB-C port for connecting to databases, I'm guessing ACP is a similar universal adapter, but for the actual software editor we type in.
Spot on. It stands for Agent Client Protocol. It totally decouples the AI coding agent from the specific code editor. You aren't forced to use one specific IDE just because you want to use a specific AI.
Okay, but what about the custom prompts I use? Like, if I spend an hour teaching an agent exactly how I like my Git commits formatted, do I really have to teach the new agent all over again?
Not if you use what they call agent skills.
Agent skills.
Yeah, instead of retyping multi-step prompts over and over, you formalize them into a reusable macro. For example, you can create a simple /changelog command.
So just changelog?
Right. The skill is just a standard folder containing your specific instructions. You author it once, and because it relies on those open standards we talked about, it instantly works across completely different AI products.
So what does this all mean? Did the course actually prove this portability in practice?
They ran an incredible demo to prove it. They took the exact same Agent Clinic branch with the exact same markdown specs and ran it simultaneously across 3 totally different AIs.
Simultaneously?
Yes. They used Claude Code to build the foundational slices. Then they booted up OpenAI Codex in the exact same repository, and it's seamlessly read the specs and executed the custom skills.
Oh.
And finally, they brought in OpenCode from JetBrains to analyze the testing posture. 3 different AI brains working perfectly on the exact same project without changing a single word in the markdown files.
That is the ultimate paradigm shift. I mean, we aren't marrying the AI model. The AI itself is really just a temporary tool. We're marrying our own intent, our own specifications.
That is the defining philosophy of spec-driven development. You retain full architectural portability. You have the complete freedom to upgrade to a faster, cheaper, or smarter agent tomorrow without breaking a single part of your workflow today.
This has been an incredibly eye-opening deep dive. Let's summarize the core value here for you listening. Spec-driven development puts you, the human, back in the driver's seat.
Exactly.
You stop being a reactive syntax checker and you step up to become the lead architect. By using a project constitution and strict feature loops, you reduce AI fatigue, you eliminate messy, drifting code bases, and honestly, you reclaim the joy of building reliable software.
You get to focus on the high-level logic and constraints, which is frankly what humans are actually best at.
Yeah.
Whenever you sit down to build with AI, remember, you are the brains, and the agent is just the muscle.
It leaves me with a pretty wild thought to mull over as we wrap up. If plain English specifications are effectively becoming the new source code that these AI compilers read, will the definition of what makes a great software engineer shift entirely in the next few years?
That is the big question.
Will the ultimate technical skill stop being syntax memorization and instead become the mastery of logic, constraint design, and clear human communication? I mean, if the AI is the contractor doing the heavy lifting, your value is entirely in the quality of your blueprint. So the next time you ask an AI to build you a house, don't just walk away. Give it a blueprint first. Thanks for listening, everyone.